Hello everyone. In this class, we are going to be looking at the topic electromagnetic waves and photon. Now the question is a question that has to do with index of refraction, that's refractive index. We have the vacuum wavelength of a light beam is 60 nanometers. What is its propagation number in a medium of refractive index 1.5? You know, refractive index has many formulas, but we're only going to use one of the formulas in this case. All right, of course, it is only one formula we can use for us to calculate the wavelength of the material medium in this case. That's according to what we have as a question. All right, you know, when we talk about index of refraction, index of refraction measures the wavelength of light in air with respect to wavelength of light in a material medium, or in terms of velocity or speed, then it will be wavelength of that speed of light in air with respect to speed of light in a material medium. But in this case, because we want to calculate the propagation number in a medium of refractive index 1.5, so the first thing we need to do is to calculate the value for the wavelength of the material medium. All right, so let's write down the given values. Now we are given lambda A, which is wavelength of light in air, that is the light beam. Okay, and the wavelength of the light beam is 60 nanometers. Now we need to convert the wavelength to what? Meters, because here we have 60 nanometers. Now 1 nano is the same as what? 10 raised to the power of, that is 1 nanometers. 1 nanometers is the same as 10 raised to the power of -9 meters. So which means the wavelength of light in air will be 60 times 10 raised to the power of -9 meters, and that will be 6 times 10 raised to the power of -8 meters. So this is the wavelength of light in air. The first thing is to convert the wavelength from nanometers to meters, and which is exactly what we have here. All right, so next we are given the index of refraction of the medium. So we have, this is one of the symbols that can be used to designate index of refraction of the medium. All right, so we have this to be index of refraction of material medium. So the index of refraction of material medium is given to be 1.5. Remember, index of refraction is a dimensionless quantity. It has no unit. Okay, it has no unit, because for us to have index of refraction to be measured as the ratio of speed of light in air to speed of light in a material medium. So that means we have ratio of two like quantities, velocity divided by velocity, so there will be no unit. So it's a dimensionless quantity. All right, so like I said, we're going to be using index of refraction of the material medium equals to wavelength of light in air over wavelength of light in a material medium. So we know that wavelength of light in air is 6 times 10 raised to the power of -8. So this will be 6 times 10 raised to the power of -8. Then wavelength of light in a medium. Now the refractive index of the material medium is 1.5. So the wavelength of light in the material medium will be 6 times 10 raised to the power of -8 divided by 1.5. Okay, now what is 6 divided by 1.5? That will be 4. All right, so we have wavelength of the material medium will be 4 times 10 raised to the power of -8 meters. So we just calculated the wavelength of the material medium. Now, but the question is for us to calculate propagation number in a medium of refractive index 1.5. So the first thing is for us to calculate the value for wavelength of the material medium, because we want to calculate the propagation number in the medium of refractive index 1.5. So which means we need to first calculate the wavelength of the material medium and then use the formula for propagation number, to calculate propagation number. Now, what is propagation number? Propagation number measures the spatial frequency of a wave. It can be used in what we call spectroscopy. Yeah, spectroscopy. In spectroscopy, it can be used to analyze the interactions between matter and electromagnetic radiations. And in measurement, propagation number can be measured as the number of waves per unit distance, and that's why the unit is always in the word per meters or per centimeters. All right, and it can be denoted with letter K. All right, so to now calculate the propagation constant, now K is the what? Propagation number, rather. Propagation number. K is the propagation number, and K is equals to 2 pi over wavelength of the material medium. So let's plug in the values. So we can say K equals to 2 multiplied by 3.142, okay, divided by wavelength of the material medium, this guy. So we have 4 times 10 raised to the power of minus 8 in meters, okay. So this will be 2 out of 4, that will be 2. So we have K equals to 3.142 divided by 2, then times 10 raised to the power of 8 per meters. Okay, so what is 3.142 divided by 2? 3.142 divided by 2 is 1.571. So K will be equals to 1.571 times 10 raised to the power of 8 per meters. So this is the what? This is the propagation number, which measures spatial frequency of a wave. And like I said, it can be used to describe the spatial frequency of a wave in what we call spectroscopy. All right, and that is because we use propagation number for the analysis of the interaction between matter and electromagnetic radiation. The noblest pleasure is the joy of understanding. Bye bye.